to basically write a paragraph for you, and models like or APIs. So ChatGPT is like an API. It's like an Uber or an app, which is a platform which you can use, which at the back end uses generative AI models, right? So basically, these are deep learning models which are based on something called transformer. Transformer is something which I will touch upon today. It's a very I will say advanced form of deep learning model, right? Which was introduced firstly by Google way back, I think in 2017, right? So the idea of Chat GPT it's a large language model, okay, guys. So basically, sorry, it has been trained on a large number of text, right? It has been trained on large number of text, and what it can do is basically it can generate things. So what do you do, like any one of you are working with any kind of Python tools? Anyone here working with Python or R? Yeah. So what happens when you get an error, right? So what we do generally, uh, we basically do and Stack Overflow. We try to Google, right? These are the things that we generally do, right? That we try to try to find in the internet that why this error is happening and all of that, है. But what through when ChatGPT came, right? So what we do, we basically put that code in ChatGPT and tell ChatGPT to do fix that code, or even give me the code, even write the code for me. And does anyone has done that, right? So basically, we are asking like in person, it's like in trainer, it's like in helper. So let's say some expert is sitting right next to you, and whatever question you have on anything, you can just ask that person, and it happens, right? You are getting the answer, right? So so all these models are based on the concept of what we refer as generative AI, or generative AI models, right? So it's basically the next league of models which has drawn a lot of curiosity and interest over the world, through which anything can happen, right? And one of a lot of use cases has come up in the current world. One of the use cases, which you might also be able to see, I'm not sure if you guys have observed it or not. So everyone uses Amazon here. Everyone uses like Amazon as app. I'm not like most of the times, right? So everyone knows Amazon, I hope. Yeah. So in Amazon, what happens? Like you will see product reviews, right? So let's say you want to buy a product. So what do you do generally? What we basically go to the obviously, after looking at the product description, we look at the reviews also. We try to see like what customers have written about it, right? Correct. That's correct. Everyone. Yeah. So we try to read the product reviews. So when we read the product reviews, based on the reviews, if the review is good, you will try to buy the product. If the review is not so good, you will try to not buy the product, right? So that's how the decision making happens. But a lot of times we become confused, right? So let's say the first review is telling good, the next review is saying waste of money, the third review is again good, right? Has it happened to anyone that you got confused in terms of different reviews telling different things, right? Has it happened to anyone? Yeah. So what happens in that case, right? So basically, and in that case, generative AI, if you have seen in Amazon, so there is a text which summarizes all the reviews which people have actually written. So it's like a text summarization. So imagine, let's say all of you write a paragraph on India, okay, and I basically take all of your essays and I summarize it into one essay, right? So basically, kind of everything in a summary way, right? And that helps a lot, right? So that is one of the use cases of generative AI, and there are a lot many use cases. You can even create a presentation, just giving some prompts, right? So create a presentation with these facts and figures, right? So it can create. So there are a lot of numerous potential opportunities of generative AI, and one of the main models that I mentioned in context of generative AI is basically your transformer models, right? So and obviously generative AI is right now has started operating even in the field of images, but it started in the image of text, right? Basically, not text data. So basically, data which is unstructured, but at the same time, which is having text in it, right? So just to give you an overview in the slide that you see, right? So in the past, what used to happen to study NLP problems, right? So NLP stands for natural language processing, guys. So when I say natural language is like a language which humans speak, right? But for computers, they cannot, or machines cannot understand natural languages, right? So they can basically not. You need to give them a command to. Sorry, you need to give them a command, right? So based on which uh, the machines can understand how we are operating, how we are talking, right? So in that case, obviously, your natural language processing comes in. So basically, you are using some kind of a machine learning or a, an analytical technique to basically process the natural language and work upon it. है ना? Now, what are the three things that has happened? So in the past, as you've seen here, right? So most of the NLP models were shallow. When I say shallow, they were more based on uh, shallow machine learning models. So like let's say a boosting model or a bagging model, like a random forest model. But these models were not very robust enough to handle large volumes of data. Also, one of the major limitations of these models were we had handcrafted features, right? So basically, someone was manually creating the features. Now, this is not scalable. So imagine, let's say you are getting a data of so many social media feeds, you will not be able to do that, right? So in that case, obviously, this is very constraining in the scale of it. Now, one of the key challenges that people used to face in the context of NLP was the curse of dimensionality, right? So what I mean by dimensionality, guys? So basically, in a natural language, right? So let's say whatever I'm speaking, is there any limited dimension to it? No, right? So the dimension is huge, right? When we are talking about natural language, if in case if you're talking about structured data, in that case, the dimension is obviously limited. You will have a certain range of columns and certain range of rows, right? But in context of natural language, the dimension is huge, and the features can be huge, right? So and one of the major problems was a sparse representation, and this is something which I will explain uh, very quickly, right? And very soon, like what I mean by sparse representation. But that's one of the challenges that we used to face, right? So now one of the trends which has happened, and generative AI is one of the like the larger evolutions of that trend, is that is that that these that there is advent of what we see as a neural based models, or models which are based out of neural networks, right? So that is what your one of the key evolutions that has happened, right? So basically using deep learning kind of models instead of typical machine learning models to predict things, you know. So now one of the key distinctions between traditional machine learning models and deep learning models is that in traditional machine learning models you do a lot of modeling and there is a less of feature engineering, as you see in the first view, right? But in context of deep learning models, there is a lot of focus on feature engineering and less on modeling, right? Now, what is the distinction between that? So the distinction between the two is that in a traditional machine learning model, you will try to iterate on the model. You will try to see like how much you can tune and hyper tune, and until you get a good result. Okay, but there is a less utility and dependency on features. Okay, but in context of deep learning models, there is a more and more focus upon uh, uh, on feature engineering, right? So basically, what we are trying to do is that we are what we are trying to do here is that instead of just modeling, we are more focusing upon the feature engineering. So now, features in context of an typical unstructured data, right? That is not something which is very uh, intuitive. So take example. Let's say I am studying data science. Now, what do you think the feature would be, right? So basically, taking a feature out of this studying data science, right? So basically, taking a feature out of this particular statement is not something which is very intuitive, right? uh, as compared to something, let's say you want to predict house prices based on, let's say, the number of rooms, right? So this is something a very well-defined feature, right? So in context of deep learning models, the idea is to basically use these kind of use the text to generate the features, right? And obviously, then the modeling happens, right? Now, that's the one of the key distinctions between the traditional machine learning models and the deep learning models, right? Now, the traditional models, as you see in the traditional machine learning models, the language is represented as a one hot encoding, right? But in deep learning, it is represented by as a vector. Okay. Now, what I mean by this, okay. So let me try to explain this. So let me share an Excel. Okay. So consider again. I hope the Excel is visible to all. Hope the Excel is visible to all. Yeah. Okay. So consider this particular statement. I like studying data science. Okay. Now in one hot encoding, and also consider the statement. Like I like working. Okay. In office. Okay. Now what I mean by one hot encoding. So basically, what will happen is that every word. Okay. Every unique word that you see in here. Okay, and we already have this, so let me write this. So in one hot encoding, what happens is that you have one, you will have one here, 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 you will have zero, zero, and zero here, right? For sentence one. And similarly in sentence two, what will happen? So this for sentence one, line one, right? In line two, what will happen? You will have this two again one, right? But in here you will have zero, 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 one, 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 right? So that is what we mean by basically uh, a one hot encoding, right? So basically you are kind of describing any particular thing to in an Boolean fashion, right? But in the advanced NLP stage, right? So we are basically representing all the words to vector, right? That's the idea. That's the advancement that has happened, right? So that's what I was representing, right? So on the left side is something which is one hot uh, vector representations, and on the right we have the vector based, right? So one hot are obviously you do not. Sorry. So as you see in the one hot, we lack the nuances. We do not handle new words, right? It's very subjective in nature. But on the other hand, vector based are extremely nuanced. You can easily it can easily incorporate new words. It's fully automatic, and it can accommodate large vocabularies, right? So that's the distinction, right? Now, this is something which we'll be applying in our model also. And transformer models is something which, as I discussed, is the backbone of generative AI models, right? Obviously, this session is not intended to, to discuss about the frameworks of transfer models, but just to give you a glimpse of what it can do. So it's basically an advancement of one of the deep learning model technique, deep learning modeling techniques, which is called RNN, or recurrent neural networks. And what it does is that it has a unique advantage of having something called as a self attention. Right now, what is the self attention? So basically, in a very simple sense, okay. Now, I'll give you a very simple example. Let's say there is a birthday party, okay, and in that birthday party, I ask you to bring the cakes. I ask you to bring the balloons. I ask you to bring the guest. I ask you to also, prepare the guest list. I ask you to also bring the food, right? I also ask you to arrange the gifts. So I am asking you to do 10 different things, right? Do you think you will be able to remember everything? Do you think you will be able to remember everything? No, right? You will not be able to remember everything that I ask you. Am I correct? Is that a correct assumption, guys? Is that a correct assumption? If I ask you to do so many things, will you be able to remember everything in same weight? No, right? So there will be few things which you might remember, few things which you might forget, right? In a similar way, specifically when you have complex long sentences, so in such cases, NLP models tend to not work as great, right? And that is where your transformer models comes. So they basically rely on this attention mechanism. So basically, it gives a weight to everything, and it can and whatever is causing a more of error, it can give more weight to it, right? So that's basically the essence of attention mechanisms, right? So that's it's something that we will be basically seeing in the code itself. So essentially, what are transformers? So it's a model, as I mentioned, which was introduced by Google, and it comes from the family of recurrent neural networks. And the advantage or the distinction of the transformer models is that it allows you to keep the attention, right? So when I say attention, it will be able to, even if it's a long sentence, even if it's a complex sentence, so even if you give a very long prompt to ChatGPT, it will still be able to answer or give you, but it will be a meaningful answer, right? So that's the and this is the paper, by the way. This is the paper which is called the attention all is all you need, right? So you can basically Google it and you will see the actual encoding or actual structure of a transformer model, right? So what we will do now, obviously, before we go into the code, it's good to know that what all transform models can do. So so there are a lot of models, and it can even take text, images, speech, even structured data. And there are a lot of tasks, a lot of impacts that it can do. It can do machine translation, it can do text summarization, it can do image captioning, so on and so forth. So it can help in a lot, many tasks, right? So that's one of the key advancements or key impacts of uh, of what we refer as transformer models, right? Does it make sense to all till here? I know I spoke a lot, but any questions? Others? Any questions? Anything which was not clear? Okay, I will take that as no questions, guys. So let me now take you guys through the presentation. Okay, or to the code. Okay, so let me reconnect. So is the collab notebook visible to all in here? Is the screen visible to all, guys? Okay, cool. So basically, the data that we will be using is something called the Flipkart data, right? Now, this Flipkart data is something which we will be uh, is obviously not an full-fledged data. It's something which is uh, sorry, it is something which we have taken as a sample extract, right? And what we will do is use this Flipkart level data and use a transformer model to basically predict or generate recommendations based on certain contents, right? Okay. So first of all, this is where I'm kind of mounting my Google Drive because the data is stored in Google Drive. Okay. Let me see if the packages work. Okay. And again, how many of you guys, by the way, are aware of Python here? How many of you guys are aware of Python here? Anyone? Uh, who is not aware? I'm not sure if it's a correct assumption, but how about others? Are you guys aware of it? I just wanted to know. Again, for some of you, the code might be very technically difficult. In case if you're not aware of it, but don't worry. Okay, most of these codes are is something which is part of the modeling framework, and actually you can just customize it with a bit of changes based on the data that you're using. Okay. So let me walk you through the libraries. So for example, NumPy is and Pandas is generally used for data handling. RE is the regex library, which is for natural language processing. TensorFlow is the deep learning package for Google, right? Keras again is a deep learning framework that which sits on top of TensorFlow. Sklearn metrics for checking for deriving the feature for the model evaluations. TF-IDF vectorizer is the way through which we discussed, right? The vector embedding. So this is how the vector embeddings are happening in here. Performance metric for science similarity is basically used for checking and ensuring that the words that are getting generated or paired, they have a similar score, right? Then there are some sub modules. NLTK is basically a very important and great package used by developed, right? I think by Stanford. So it's natural language training toolkit where you have a lot of dependencies which will be required uh, for building the any kind of an NLP pipeline, right? So yeah, so basically in this case is where we are importing BERT. So BERT is like a transform model as I discussed. So it's one of the most good, I would say, models that was developed prior to ChatGPT. So there's something which has been there, right? And obviously, ChatGPT as a model is kind of inspired by Transformer, right? And even BERT uses Transformer as a framework, right? So that's where we are importing that. This is where I'm just changing my working directory, and I hope, yeah, and this is the data, right? So let me try to uh, show you the data and show you the columns once. Okay, so okay, let me see if I have it correctly. So we have the DF. Okay, so these are the unique columns, right? So we have something like a unique ID. That we have the timestamp, we have the product URL, we have the product name. Let me show you the data itself. me see if why it's not showing it. Is it to yeah something? But anyways, I can yeah okay. We have it in here. It's not in the right. It's a too long a description, right? So basically, we have columns, and that's the reason maybe I can take you through the. So this is the data format, right? So what all columns you have? You have a unique ID, you have a crawl timestamp, you have a product URL, you have a product name, you have a product category, you have something like a product ID, you have a retail price, you have a discounted price, you have an image, you have an advantage product or not, you have a description of the product, you have product rating, you have overall rating, you have a brand, and you have a product specification, right? Now the idea is that using the data that we have, right? Basically the product description, we should be able to recommend uh, things. Okay. Uh, so the idea is that, and let me try to show you the first thing. Okay, so the first thing is that we will be basically obviously filtering some of the columns. We will not be using all the columns right in here. So that includes the product ID, the product name, the brand, description, discount price, and product specification, right? So obviously, we would also want to retain the product name because that's something which you want to recommend, right? So that's what we are doing in here. Okay. Uh, just to check the information or the total the total structure of the data. So we have around 20,000 entries, right? And how many columns do we have, right? So I think we can quickly check that using the shape. Yeah, I think we have a total of 6 columns and sorry, and we have around 20,000 rows, right? So that's the shape of the data. Okay. We are also removing and checking if there are any duplicates or not. So even after removing the duplicates, we have the same. So there are no duplicates, right? The next thing that we're doing is that first we are converting everything to string, and we are also making everything to lowercase just to make it consistent, right? So now if you see product specification, right? So this is for the first row. That's how the product specification looks like. So you will see this column contains raw text, right? And even it has got some key value pairs, right? So value pack of 3, key fabric, value cotton, right? So on and so forth. So it has got the values in the key value pair, right? So what you would want is to basically format this data because we cannot use this data actually, right, in the correct format. Uh, no worries, I think, Abhishek. But the idea is that we cannot basically use this data as it is. So we would want to reformat this data, right, so that we can extract. Okay, so let me try to show you that. So if you see now applying this function instead of having the data in this particular format, right, like in this key value pair, we are able to have it in the format of like number of contents is say package is 3, and we have it in the correct form, right? Now we also want to kind of clean so this part is more of data cleansing, which is something which is very important in any context of data, right? So we clean the color information, right? So we create a function where we are basically filling in the color details. Okay. And these are the colors which we want to remove, right? So anywhere we basically find these colors, we are basically removing these colors, right? Because we do not want this to, because color is something we are not concerned of. We are more concerned about recommending these certain products or brands, right? The next thing in terms of cleansing is that we also want to remove any kind of alphanumeric characters, uh, which is obviously more of a stop noise, right? The next thing is that we are generating something called a combined text, which is a combination of product name, description, and product specification, right? So basically, this is what uh, on which we'll be applying the model. So this is like how the combined text looks like. So as I said, it's a combination of your product name, it's a combination of your description as well as your product specification. So this is like the entire text that we have, right? So till here, till this part, what we are doing is we are basically cleansing the data, right? Cleaning the data just to ensure that we have everything in place, right? And after this is where we are introducing BERT as a model. So the first is that we are calling the sentence transformers, right? So this is the model. This is the part where this is the part we are just calling BERT. We are not applying it yet, right? And now what we will be doing, we are using the BERT model to generate the embeddings, right? So basically, we cannot use text in any kind of a deep learning model. What we are doing is we want to basically make it as numerical numbers, right? So if I show you, and this will take some time, guys, to run because obviously it's a deep learning model, and maybe for one of the value I can show you. But till then, any questions, guys? Till here, any major thing which was not clear, let me know. Anything, any confusions, anything which you want to ask? Till here, following, guys? I hope everyone. I hope that silence is not about you're not following it. I hope that silence is no questions. Let me Priyanshu, Sony, Vishek, Shubham, Umesh, Sahil, let me know if any questions. Rishabh, till here, anything, let me know. If even if the question is not directly from the code, feel free. I think we can take this time when the model is when it's getting run. We can take your questions. Okay, Abhishek says a no. Others? So I understand that it's not a model which can be very clear in just 1 hour of time. But I hope you are getting the gist of it, right? So the idea again in any kind of transform model is, as I mentioned, is it's based on a deep learning framework, but it is taking into account the semantics and the context of the sentence to generate predictions. Okay, I think we have got it. We have generated our sentence embeddings, and this becomes the first part, right? So if you see, now everything is in terms of a matrix, right? So there is no longer words, uh, because obviously what we are trying here is we are basically taking uh, the words, and we are kind of converting into an embedding, right? And this is where the path is. Now, what we are doing is as I mentioned initially, we are converting the query to lowercase. So just to ensure that whatever query that I pass, I can get the right recommendations. That should not hamper my recommendations. And we are also converting the brand to lowercase, right? So basically, this is the query, right? And this is where we are saving the embeddings. Now, what we are eventually doing, so BERT is like it's a pre-trained model. Okay, so we will not train the model here. So there is a model which has already been trained by huge pipelines of the data, right? And that pipeline is being used to basically compute, right? And we can basically leverage that pipeline to predict something. You know? So now what we do in here is, and let me show you. So this is the part where we are loading the embedding part. So let me quickly explain what this code is doing. Okay. So it's a function, obviously. So this is the function where we are basically generating the recommendations, right? So whatever input that they give, based on the input, we are trying to apply and weight, right? And using the embeddings, right? And and whatever. brands, right, which are whichever or whatever products which are like similar or common to the query which we are sending, it will basically give me that, right? So let's say, and let me run it and this will become more clear. So let's say I want to, this is my input list, right? So the Bluetooth head, wired, wireless. So I'm searching for, let's say, Bluetooth headphones, right? Wired and wireless. And also trying to search for running shoes, car mats, tea start, and all of that. So let's say these are my the queries that I run. Now, like in Amazon, right? It will give you certain products. Here also that you see, it gives me all the products which have the most common similarity to the input that I am generating, right? It's the same way like that happens in Flipkart or Amazon, right? Uh, so, so the idea is that we can specify those uh, keys or those prompts, right? And through that we will be able to get the recommendations, just like we get in any typical uh, platform, right? Like an Amazon or a Flipkart and so on and so forth, right? So you see there is a recommendation format, there's a recommendation, for everything that we are having, you know. So that's the idea. And as you have observed that we did not train any model again, we used and predefined BERT model. And and if you see the recommendation outputs, these are pretty solid, right? These are pretty good in terms of giving you very relevant recommendations. It's not showing some any garbage output, right? So these are the t-shirts categories which it is showing. These are the recommendations for jewelries, right, and so on and so forth, right? So obviously you can basically change this, and obviously it has to be again logical queries, and it should match with what you have in the or similar products which you have it in the input, right? But it should be able to give you very strong, right? And the similar kind of models are actually applied by the e-commerce platform giants, right? To recommend products to us. So that's is what is happening in the backend as well, right? I think this code is something which is already Rakiv has shared with you guys, the links, right? So feel free to play with the code, even change the input list, change if you want to if you want to check with more products, right, with more product categories and so on and so forth. And I'm sure this can be a very useful beginning of understanding of what uh, you know uh, recommendation systems are based on NLP, right? So I think that's what I had or we had for this session. Yeah. But I hope it was a useful one, right? And I hope you guys got some idea of what transformers are, got some idea of what generative AI does, right? And also got some idea of what and how these models can be implemented in Python. But I will maybe leave the next few minutes for any questions you guys have, and happy to take them. So this is basically how website summarizes an output. Exactly. This is how the website takes so any queries or any prompts which you give, like you go to the search menu bar and you type in that anything, and that's how it ranks. So obviously there are, let's say, thousands and millions of products, right? But you will not see every product in your screen, right? You'll see maybe the first five and 10, and so that's how exactly it works. You're correct. What about others? Any other questions? Abhishek, let me know if no, it's basically like a ranking. It's not like a Boolean. It's more of a ranking, right? Uh, and based on that, you are trying to recommend the products. So it's not like it will just zero in out of one. It's like out of hundreds of products, you will be giving certain recommendations. Does it make sense, Abhishek, for you? Others? Any questions? Any thoughts? I hope you realize the potential and got some idea of the backend thing that's happening, right? And I'm sure like you guys um, definitely might be interested of how do these things work, right? So it's just an idea of like how like a preliminary idea of how things work. Obviously, a lot of details and granularity towards it, but yeah, the idea was to just to show you guys a glimpse of what's and how these kind of models work. Okay, cool. If no questions, I think we are almost on time, guys. Okay, I'll take that as a no. Thank you all, I think, for again attending this short webinar. And I'm sure you guys, and I hope you guys did like it and did enjoy it. Yeah. So, yeah, all the very best. And I'm sure you guys all be doing good. Yeah. Cool. Thank you. All the very best. Take care, guys. And yeah, in case if any questions, feel free to reach out to the team. Thanks all. Bye bye.